Good evening, everyone. So today we would be covering the next part, right, of the previous session, which we discussed, and which we discussed was some demo on a small local cluster of ours, right? We tried simulating a situation wherein we had a master node, and then there were two compute nodes or two worker nodes, right? This was what we did in the previous session. Now in this session, what are we going to do is we are trying to understand that how do you deploy, right, a machine learning program. We'll be taking an example of how basically you can develop that type of a program, put it onto a Kubernetes cluster, and then we'll also try to see some other recent developments in monitoring Kubernetes cluster as a whole, right? We'll try to see one or two very basic, very nice, okay, dashboards which will help you to understand things much more better. And as you go along this course, you will understand that once you start developing your programs using this type of approach, which we have discussed in the previous class and then this class, you will really appreciate as to how a lot of work which you are supposed to do would be done by such systems, right? So let us start with the agenda for the day. We would be discussing a bit of Kubernetes and Slurm in a manner that we'll try to just have one slide of trying to understand how they both are linked. Try to link it with something which is called as DevOps, which links with MLOps, then DeepOps, and then we will give a demo of how you can create your own machine learning program, right? Create it as a pod and then put it onto some cluster for execution, right? So we will do a prediction analysis of a placement this thing scenario, right? And we will share the links also in the Slack for you to actually work on it. And then there would be a demo of a very recent, very well, what to say, well designed GUI, okay, for managing your cluster. So let us try to understand this. We saw this, right? Kubernetes, we had to create a job, right? We had to create a job. 1 minute. Sorry. We had to create a job, okay? And then through the API, you send it to the master node, and then just reduce this thing so that no, it's good for me. One sec. Yeah. So yes. So the idea is that we have this API, okay, which actually helps us to create a job, which basically is to be controlled by a master node and which actually has to run on one of these worker nodes as a pod, right? Now here, this worker node can actually have a GPU. It may not have a GPU, right? So in case it has a GPU, you would basically have to install the appropriate CUDA drivers and all that stuff, right? So based on whether that has a GPU, it does not have a GPU, you will have to set in the environment for the worker node, right? But the effective idea is you can create this using this a job and run it on a worker node as a pod. So this is what we are going to actually do today, okay? And then you have a command line interface also. Of course, it is basically terminal which you generally use, so we will have that as well. So this is how basically the Kubernetes is setup, right? And then we saw certain basic terminologies just to have a recapitulation of what we actually talked about. So kubelet is an agent which runs on each node in the cluster and is responsible for making sure that the containers are running in a pod, right? So that is basically a kubelet. Okay, and then you have this kubectl. This is the CLI for communication with a K8 cluster or whatever for deploying, right? Then manifest is basically the configuration as a full metadata, right, which defines a Kubernetes object. Usually these files are written in YAML. We will see and edit a YAML file as well. And then there is a node which we know, which is basically a server in the K8 cluster. Pod is the smallest atomic object on that particular node. Job is a finite or a batch task that runs to completion, which launches a pod. Replicas we saw are replicated pods in the cluster, and K8 objects to maintain API keys, passwords, and all this. We saw what is a secret thing, right? And then we have surveys, and then deployment are K8 objects which encapsulate an entire application, right? Which includes a pod definition, service, this, that, everything. So this is what is a general basic Kubernetes terminology, right? And we will see a few of them today, right? And then let us try to understand Slurm. Slurm basically is simple Linux utility for resource management. This you saw in one of the previous classes, right? And what it does, it basically again does no the same thing of scheduling, and but it is basically used for the HPC resource management and job scheduling. But when you see Kubernetes, it does so many things automatically, right? This also does automatically, but this basically is a older concept, right, than the existing Kubernetes concept. So that's how it is, right? Because initially people used to work on high performance computing systems, and there were basically all high compute requirements, so only few people would be given the chance to work on it. So you had to have a scheduling type of mechanism. So this is how it actually started. Now if you see from the client's perspective or the customer needs perspective, you have got two things, right? One is the Kubernetes way of implementing things, another one is some way of implementing things. So Kubernetes, if you see, you can share the node, schedule the jobs for GPU on a node, right? Something like that. And then you can give permissions, security, you can do analytics and monitoring. This is what we will see today also. And then these advanced thing like Slurm is for multi-node jobs. You have DAGs. We will discuss this in our future classes. What about reservation, ticketing, and then there is a scheduling, right, and certain other functionality. So this is how actually it is a bit differentiated, right? Now coming down to how the implementation happens, right? So Kubernetes basically, is used for a cloud-like situation. So it is service-oriented, it's containerized, it can be scaled, and it does load balancing on its own, and it will ensure that your quality of service is maintained and it keeps the applications running. Whereas in case of HPC, when you talk, right, it is basically a batch type work, right? So batch type job oriented things, you run it on a bare metal. You can also allocate resources, and the user control, right, can be fine grained to certain specific levels, right? And it will also ensure that system utilization is maximum. So these are certain broad differences, right, as to how people try to do all of this. Now let us try to understand how is this linked to DevOps. Now what is DevOps, right? DevOps is a set of practices that have made it possible to ship a software to production in minutes and to keep it running reliably. That basically means you have two things, right? One is the development of your software and another one is the operation of what you are going to maintain, right? So there are two different aspects. So development and operations. So when you mix both of them, it becomes DevOps. So if you develop a software, you are developing it. Once you develop it, it has to be operational, right? And that is what is DevOps, right? So what does DevOps actually do? So if you see the development portion of it, you have to plan, code, build, test. Okay, so you have to plan, code, build and test. Then once you do this for your software, you release it, and once you release it, you have to deploy it, operate it, monitor it. So this portion is the operational part of your project implementation, whereas this is what is the development part of your project implementation phase. Now when we say DevOps is going to actually help us coordinate between these two phases. Okay, and when you say they are actually coordinating between these two phases, DevOps is going to rely on tools, automation and workflows to abstract away the accidental complexity. So the idea is this, that it ensures that automation and workflow, okay, is actually implemented, or you are able to implement it without any complexity, and let the developers focus on the actual problem that needs to be solved. So till now, you have seen, of course, it may be very overwhelming in the beginning itself to understand about Kubernetes or Dockers and all of this. But once you actually implement these type of algorithms in the days to come, you will really appreciate as to how Docker is very useful for your own use, or how Kubernetes is of very easy thing, right, for maintaining so many people trying to share a single cluster. So gradually you'll actually appreciate all of this in the days to come. So that is the reason why you should know actually how this particular thing, right, or the coordination between the DevOps people who are actually trying to manage things and people who develop, okay, need to be actually streamlined and understood. Okay, so let us try to now come to the next version of DevOps, which is for the people who actually do machine learning development and deep learning development, right? So we call it as MLOps. When you say MLOps, it came from actually DevOps, because you are trying to develop your software or develop your project. At the same time, you will have to implement it, deploy it, see that it is operational, and see that people are using it, right? So it also has got two things, the development and the operational aspect of it. And since it is related to machine learning, MLOps came into the picture. Now there is a very basic vast difference, right, between the way in which the ML projects are managed and operated vis-a-vis a general software, or a general software project for that matter. Why is it different? Machine learning project or a machine learning software, it is not just a code. We should understand that it's code plus data. Okay, now this basically means that you have got a situation like this, where you are having this data also, the program or application code also, then you do a training process or do whatever, okay, onto some model or whatever you do, but you have got the software code as well as the data to be used with it. But in case of a general software development, you generally work with code, right? So this is one of the very major differences between the DevOps thing and how it has actually gone to the next level of MLOps. And when we talk of DeepOps, it is still more complicated in a sense that when a project is developed, to maintain it, to operate it, to operationalize it, it is at the next level of MLOps, right? So in all these three cases, Kubernetes is the major central block which ensures that you can operate, you can deploy, you can schedule, you can coordinate, you can orchestrate all of this very successfully. So it supports all of it, right? So okay, so now let us go a bit of a detail into it as to when we say the data is there, the code is there. So when we say that code is carefully written, while the code is carefully written in a restricted development environment, data generally comes from the real world, right? So let us say you develop a model. You have written your code, you have created your model, you have created your software application. You would have thought that data would be of this type, it should have these features, it will have these characteristics, okay, and it is from this type of a modality, everything fine. But when it starts coming from the real world, right, it will be a bit of a changed scenario, or it will never stop changing, and we don't have control, or you don't have control on how it's going to change. So technically speaking, the data and the code in case of MLOps is going to evolve independently, right? So we think of them as a separate plane with a common time dimension to some extent. Now, when you say that there is a ML process which needs to be maintained, so the challenge of a ML process is to create a bridge between these two planes such that it actually synchronizes and orchestrates the things very effectively. So this is how ML ops actually needs to be understood, right? So we can again come up to a basic definition or a basic understanding of ML ops as a set of practices that combine machine learning, data engineering or data processing, and then this is what is DevOps. So MLOps is a set of practice that actually combines machine learning, data engineering, and DevOps, which aims to deploy and maintain machine learning systems in production reliably and efficiently. So ultimately, you are going to ensure the terms which people talk in terms of cloud now, that I should have this much quality of service, I should have this much bandwidth, I should have these much resources, I should have this much memory, I should have these many CPUs, I should have these many compute elements or whatever, right? So you need to ensure that your machine learning application, okay, satisfies all that, because we are talking of production environment, reliability, and efficiency. So we have now come down to a level wherein we can now appreciate that how it has evolved from DevOps to MLOps. Now let us try to go a bit into what a MLOps is. A data pipeline, as we see here, which is in the next diagram. So there will be machine learning pipeline, right? So a data pipeline also is a basic pipeline which is a series of transformations that are applied to data between its source and a destination. So you can give your data as an input to one of the sequence of modules through which the data has to pass. It has to come to a destination. So in between that, whatever is that pipeline, that basically becomes a data pipeline. Now, ML models require some type of data transformations, and it depends on your application though, right? But it requires some type of data transformation. Now, this type of data transformation, either you write in some scripts or you write some cells in a notebook, Jupyter notebook or whatever, which actually makes them hard to manage and run reliably. Please understand this, that we know that our machine learning model will require certain types of data transformation, and which we generally do by writing scripts very fast, or we put it in a Jupyter notebook, and there will be so many cells which will do that. But gradually, in the long run, how do you manage them and run those things reliably is very important. So using proper data pipeline provides many advantages in code reuse though. Runtime, visibility, management and scalability are also actually improved, right? But how do you design a proper data pipeline? And then how do you ensure that this ML transformation and this data pipeline, right, okay, are actually coordinated? Okay, so we'll see what does it mean. So most versions have two pipelines, one for training and other for serving. So this basically means what? Now we are talking of our application which actually has to do some task like classification, object detection, recognition, x number of applications it can do. It will have two separate pipelines, right? One for training and one for serving. Okay, so when we say it is for serving, that basically means people will use it, right? So we will have to give people to use it, and that is the testing phase of our application. That's what we say, right? So we want people to use it, so that's where serving comes, right? So the ML pipeline is pure code artifact independent from specific data instances. So ML pipeline does not have any interference with the data pipeline, whereas data pipeline is totally separate from the ML pipeline. And then you assume it that you have two types of pipeline, right? One is for training and another one is serving, right? So this is how it is. You take the data, you transform it appropriately, right? So there will be a ML pipeline, there will be a model which will be trained using this type of a training mechanism. Then you have a code which will actually be actually training this, developing this trained model, right? Training model for that matter. And then once this is done, you again give in the data to the serving pipeline, and then you do the prediction. So this CI/CD, okay, combined practice of continuous integration and continuous delivery or continuous deployment. So try understanding that as we go along this particular axis, you should actually go on doing so many things, right? You should have continuous integration, you should have continuous delivery, you should have continuous deployment. All of this go hand in hand, but you should ensure that everything happens so seamlessly smooth, right, that we will try to actually synchronize things, right, and then do basically a very good uh, efficient, okay, system for synchronizing and orchestrating all of them. Okay, so let us try to actually understand a bit of a similarity okay, between the DevOps and MLOps and the differences between both of them. So see, DevOps was developed to maintain version control, maintain good pipelines, to understand behavior validation, CI/CD, continuous deployment, okay, then data validation for some matter, and monitoring. So then DevOps and MLOps actually are, in a sense, that you have this code version control, and data lineage, code version control plus data versioning plus model versioning. So since when people started developing this code version control on DevOps, because at that time it was only DevOps, okay, then you had this data lineage also linked to code version control. You went and mixed both of them to get a MLOps type of a thing, which is code version control plus data versioning plus model versioning. And you should ensure actually that it basically meant, okay, that you are going to link DevOps with data engineering plus adding this model based versioning thing into it, right? So when you talked of this pipeline, initially DevOps did not have any concept of pipelines, because you only had to ensure control version control and no something like that. But when you talk of data engineering, you surely had a data pipeline, the extract ETL, okay. So when you had this ETL and data pipeline in data engineering, the MLOps was bit modified into training ML pipeline and serving ML pipeline. Then behavioral validations, you had unit tests, but in case of MLOps, obviously you will have to have model validations. And when you talk of CI/CD, okay, deploys code to production, deploys code to data pipeline, deploys code to production plus training ML pipeline. So these are certain differences, that how do you actually try to do all of this. Then data validation, right? What type of data needs to be validated? In case of DevOps, since there was no data, so there was no question of data validation as such. But when it came down to data engineering, you had this format and business validation. And when you talked of MLOps, you had this statistical validation, right? And when you talked of monitoring all of these operations, right, in case of DevOps, in case of data engineering, in case of MLOps, right, you use something called as service level objective, right, or service level agreements or whatever, right? So in that case, monitoring was done on service level agreement types, here also, here also. Then in case of MLOps, right, there are service level objectives, service level agreements. Then there is something called as differential monitoring and statistical slice monitoring. This basically is an advanced version of trying to monitor things, right? We're not going into the details of any of this, but trying to link the DevOps with MLOps, right, along with the new pipeline which got introduced because of data engineering, right?